Hi there. So this kind of mini video, I've made a couple of little bits, is trying to convince you guys that the product of two negatives is a positive. We've often been told that that's the case at school. Sometimes convincingly, it's like that takeaway. Just sort of deal with it, and that's not how I work. I need to see proofs. I need to see where things actually come from. I remember my physics teacher during my A levels just used to put things up on the board and say, this is a fact, deal with it. And I used to question this, and much to his irritation. But so I'm going to start off with a basic, and I use the word proof that the product of two negatives is positive, by starting off with the expansion of a minus b all squared. Now, this proof, at best, I think is tenuous. I'll get to why I'm not entirely happy with this one, and I will follow it up with something a little bit more rigorous and more convincing. Now, if I were to multiply that out, I would clearly get a minus b multiplied by itself. Okay, and that would become a squared minus ab minus ab, so minus 2ab. Now, ordinarily I would write plus b squared, suggesting that negative b multiplied by negative b is itself positive b squared. I'm not going to do that. I'm going to write plus some unknown quantity c. Now, we are now going to put this in a specific situation, and this is where I think this argument falls apart. I'm going to say that a is equal to b, so therefore a minus b all squared, okay, means that that's obviously equal to 0. Okay, so if I now suggest that this a squared minus 2ab plus our unknown quantity c is also equal to 0, it must be, okay, and I know that b and a are equal to one another, so I can rewrite that minus 2ab is minus 2a squared, okay, and I end up with negative a squared collecting these two terms, plus c is equal to 0, so c must be equal itself to positive a squared. Okay, so and I know a and b are equal, okay, so I can also say that c is equal to b squared. Okay, so that says that our unknown quantity c, which is the product of negative b and negative b, is itself positive b squared. Now, the reason I don't like this particular argument is it actually relies upon the fact that a and b are equal. So have we proved it for all cases? No, we haven't. We've proved it in a situation where a and b are equal. And that's where the argument falls apart. So on to the next bit. So for the next exciting instalment, I'm no longer going to say that a and b are actually equal. I'm going to simply say that a and b are both positive. Okay, so just a basic statement about the nature of a and b. Now, if I then take the negative value of a and multiply that by 0, okay, negative a obviously being a negative version of the positive value a, so itself a negative number, multiplied by 0 must be 0, because anything multiplied by 0 will be 0. It's called an axiom, a self-evident truth, so we can use this. Now, instead of 0, I'm just going to use my second unknown variable, which is not itself equal to a, as b minus b. So that's going to be our new version of 0. So we are now going to end up with negative a multiplied by b subtract b. And once again, that still must be 0 because that's still true. And we end up with an associative multiplication, expansion of these brackets. Now, I know that negative a times b is negative ab. That's not something that we're debating here. Okay, but what we are debating is negative a times negative b. I'm just going to simply put that as it stands, negative a times negative b. So I'm not making any statement about this. I'm simply saying that it's the product of these two negative values. So I'm now going to rearrange this a little bit, add ab to both sides. Okay, thus cancelling that left-hand term. And I've got our negative a multiplied by negative b equals ab. So what does that actually tell us? Well, we've already stated right at the top that both A and B are positive. So therefore the product of two positives itself is positive. Again, not something that needs debating because it's simple fact. Okay, so therefore we know that negative A multiplied by negative B itself must also be positive, regardless of what A and B are. Okay, and numerically, therefore, negative A multiplied by negative B must be the positive product of A and B. Okay, so I hope that was a little bit more convincing than the previous iteration, the previous attempt, because we're not making anything specific about this example. This just assumes that both A and B are any positive real numbers. Okay, I hope that makes some sense.